Dear friends, in other videos we talk about the AHUs. This is your AHU, is moving air through the system. But there it is cooled, heated, it's got its humidity removed or humidity will be added to the air. The air that moves through the AHU, it is monitored and controlled by special equipment, differential pressure modules, and fans, programmable logic controls. And all this equipment is meant to keep the air constant. The air handling unit brings air into the premises via the ducted system, and the ducts must be provided with a constant air volume and variable air volume. That's why we'll know our quantity of air that goes into the premises will not be compromised. It does not only control the air velocity but also control the air temperature and humidity. To control the humidity, we use heat exchangers. Like in this case, we have a cooling agent that passes by through the heat exchanger. So this cooling agent is regulated by a three-way valve, which is controlled by an actuator. So even if we use heater, coolers, or both, the cooling and heating agent will be controlled by a programmable logic control. We will instruct the valve to operate more or less according to the heating or cooling demand. Like I said, a HVAC engineer will write the control philosophy and the software engineer will apply this onto the PLC, and then the PLC will control the air handling unit accordingly, will control the fan speed, will control the heating and the cooling heat exchanger. Even the chiller can be controlled by the same programmable logic control. The heating and cooling or the dehumidification process will be controlled by actuators, which will allow the heating or cooling agent to pass by to the heat exchanger. Like in this case, it can be all or nothing, or it can be proportional. As you will see in this case, the glycol goes through both ways. Unfortunately, sometimes bad things happen. As you will see, this shaft of the valve, it is broken. The actuator tried to close the circuit, but it can't. And look what will happen now. I don't have a heat demand, but the valve is seized, and then my premises will continue to heat. A proportional control is great because I don't have to open 100% the heating agent to go into the heat exchanger or to close it 100%. I can have a proportional control which will control the heating capacity of the heat exchanger, and then I will have a very nice trend when I'm heating the premises. Now we understood we can control the heating or cooling agent flow, but what gives us this cooling capacity? Where this cooling agent is coming from? Where the heating agent is coming from? Maybe you ask yourself, well, where this cooling agent comes from? So to cool the cooling agent, which can be water or glycol, we use chillers. So the chiller have two sections. One section is a refrigeration system and one section is the water circulating. So also we have a plate heat exchanger. So the refrigerant, very cold refrigerant, circulate through a plate heat exchanger, and the water circulates through the same plate exchanger, but they are not touching each other. So the refrigerant absorbs the heat from the water or the glycol, and then the water or the glycol get very cold. Also the pump makes sure that we have a constant flow. Otherwise, the three-way valves which regulate the flow to the heat exchanger will not have a very efficient function. So see that little green pump which moves, that pumps will bring a constant glycol flow into the system, and the chiller will try to keep a constant temperature. I will talk about this in other videos, but what do we have to know? By having a constant temperature onto the flow and constant flow, the three-way valve will help to regulate the delta T in between flow and return onto the heat exchanger. It is very important for you to remember this. If the cooling glycol gets hot, then you have to go and to look into the chiller. Maybe two of the compressors are off, maybe all the compressor will be off, maybe you have some faults in a refrigeration system which is not allowing the refrigeration group to cool the cooling agent. Then the cooling agent will lose the property. You will have an increase on the glycol flow temperature. And if you'll have that increase, the actuators which control the flow onto the heat exchanger will open 100% because they will be starved of capacity. The thermostat inside the room will say, okay, it is very hot. We'll send an instruction to the PLC, and the PLC will instruct the actuator to open 100%. Even if you'll open this actuator 100% and the flow will run freely through the heat exchanger, because the heating agent will have a high temperature, you will never cool the premises. Now you can see how the actuator is controlling the cooling heat exchanger's capacity. It will allow more or less glycol to pass by through the heat exchanger, so the heat exchanger will cool more or less the air that cools the premises. Also, this actuator will control the dehumidification process. To achieve a very good temperature cooling control, our chiller must be in perfect condition. The flow should be constant. The temperature of the flow must be constant. A healthy chiller will give us the correct quantity of glycol under the right temperature. Any malfunction of the chiller will be instantly felt by the heat exchanger and ultimately by the premises that need to be cooled, or they will need their air to be dehumidified. The air can be cooled, it can be heated, or maybe we need to dehumidify the air and then we have to reheat it again, as you will see in this video. Now let's talk about the heating. What heats the heating agent? They should be boilers or any other source of heat, but let's talk about boilers. Boilers are designed to heat the agent for the heat exchangers, and also the boiler can heat the domestic hot water. There are many types of boilers and many types of applications. The boilers can have the capacity to heat either the heat exchanger and the hot water, but not in the same time. So anytime you choose a boiler for the right application, you have to make sure you have enough capacity to do both, if this will be required. I will talk about this in other videos. Thank you.